With a final closing bid of $4.28 million, an anonymous buyer just became the new owner of the 555.55 carat black diamond known as the Enigma. The sale of this bizarre stone has reignited a long-simmering debate about where it came from, stoked by the controversial theory that it may have arrived from outer space. The Enigma and all other carbonado diamonds formed in a mysterious event some 3.8 to 2.6 billion years ago. They are found in only two regions of the world, Brazil and the Central African Republic, and can grow astonishingly large. The group includes the hulking 167-carat Brazilian carbonado known as Sergi, the largest diamond ever found. And the Enigma itself is no small rock at nearly the size of a racquetball. This is a pretty honking big diamond, says Thomas Stahel, a mineralogist specializing in diamonds at the University of Alberta. Until recently, though, carbonados were recognized not for their beauty but for their toughness. Unlike the single crystals of traditional gem diamonds, carbonados are made up of an interlocking network of crystals, which imparts extra resistance to fracturing under pressure and makes them valuable as industrial abrasives. Carbonados' many oddities have led to a slew of theories about their origin. There's no single model that explains everything, says Wui Wang, Vice President of Research and Development at the Gemological Institute of America, who certified the Enigma as a natural carbonado. Burnt diamonds. The story of these ultra-tough minerals unfolds in two spots on either side of the Atlantic Ocean. Black diamonds were discovered in the 1840s by miners in eastern Brazil who named the minerals carbonado after the Portuguese word for burnt or carbonized. Decades later, carbonados also turned up in the Central African Republic, the only other place they've ever been found. The carbonados at these two locations are so similar in minute details that they must be related, says Peter Heaney. Through the millennia, wind and water have erased most other clues to the black diamond's origins, eroding the rocks that the gems formed in and scattering the grains along the shores of ancient rivers. Around 150 years ago, a similar problem shrouded the origins of the type of diamond that is most commonly mined today, says Pierre Cardigny, a geochemist who specializes in diamonds at the Paris Globe Institute of Physics. Answers began to take shape in the 1870s when the diamonds were found embedded in vertical pipes of volcanic rock in the Kimberley area of South Africa. As scientists later realized, violent volcanic eruptions blasted these conduits to the surface, dragging the stones now known as kimberlite diamonds from deep underground with a surge of magma. For the carbonados, Cardigny says, were basically back 150 years ago. Without a host rock, scientists can only search for clues in the odd features of the black diamonds themselves, but each one seems to tell a different story. Befitting its name, no one knows exactly where on earth the Enigma comes from. The diamond was estimated to be more than 800 carats, equivalent to 160 grams, when it was purchased anonymously in the 1990s, according to the seller's representative. It was later cut into its distinctive 55-facet shape, a task that took 3 years because of the stone's extraordinary toughness. By meteorite or mantle. As diamonds crystallize in the immense pressures deep within Earth, they occasionally encapsulate minerals from the planet's mantle, such as deep red garnet or green olivine. But these minerals are absent in carbonados. Instead, geologists have found an exotic array of metals, such as the titanium nitride mineral osbornite, which is most commonly found in meteorites. Perhaps the diamonds formed on carbon-rich stars or planets, bits of which were carried to Earth in meteorites during a period between 4 and 3.8 billion years ago when space rocks regularly pelted our planet. Stephen Haggerty, a diamond geophysicist at Florida International University, initially proposed this extraterrestrial origin at the 1996 conference of the American Geophysical Union, and he still vehemently contends this is the only logical explanation for the carbonados' many curiosities. I would be absolutely delighted if someone comes up with a scientifically robust alternative, he says. Other scientists aren't so sure. When Penn State's Heaney first began studying carbonados in the 1990s, the meteorite proposal seemed a logical explanation. But the more black diamonds he analyzed, the more likely it seemed to him that they formed in Earth's mantle. He points out that scientists have identified some of the same exotic metals in kimberlite diamonds. And osbornite, while rare, has also been found encapsulated in minerals and rocks formed deep in Earth's mantle. But the evidence that truly changed Heaney's mind was the tremendous size of many carbonados. Diamonds have been found in meteorites or formed by the intense heat and pressure of meteorite impacts, but these extraterrestrial stones are all tiny. It's nothing like a jewel, Cardigny says. You couldn't make anything of. The precise conditions in the mantle that would allow for carbonado formation remain uncertain. One puzzling feature is that all carbonados are filled with holes, like sponges. Most Earth diamonds form at least 100 miles below the surface in sizzling temperatures and crushing pressures. Pores couldn't survive such conditions. They would simply collapse on themselves. Haggarty says, noting instead that such pores could have formed as molten carbon degassed on the surface of dying stars. Other research suggests the pores may be the result of carbonados crystallizing from hot subterranean fluids, or perhaps the cavities were once filled with minerals that have long since washed away. Heaney suggests the cavities may have once contained phosphate minerals enriched in radioactive elements, which could have damaged the diamond's crystal lattice structure and darkened the diamond's color as they decayed. The interconnected networks of pores, however, make it difficult to study any remaining material, since it's not easy to tell whether inclusions are original or minerals that formed later in the diamond's life, Cardigny says. The carbonado really is a difficult problem, Stahel says, adding that the key may lie in the chemistry of the diamonds themselves. Chemical curiosities. While diamonds are entirely composed of carbon, the element can take the form of heavy or light isotopes. True to their nature as enigmas, carbonado's isotope signature differs from most common diamonds. It's much lighter than diamonds that form deep inside Earth, more similar to the organic carbon that makes up life. Some scientists suggest that this light carbon signature could mean carbonados formed from organic material dragged deep under the surface in subduction zones, a mechanism previously proposed for the formation of some common diamonds. Some 3 billion years ago, when carbonados were forming, life would have just started to take shape. Are carbonados fossils of the very earliest organisms to form on Earth? Heaney wonders. Nobody knows the answer to that. But Cardigny and his colleagues found a clue that hints at another source. In 2010, the researchers found diamonds with a strikingly similar chemistry to carbonados in French Guiana. The diamonds were embedded in komatiite, a type of volcanic rock from excessively hot and liquidy lavas that only flowed early in Earth's history. While these diamonds' structure differed from carbonados' mashup of multiple crystals, Cardigny suggests that the searing heat of the komatiite lavas could spur the crystals to take on carbonado-like forms. We cannot reject any more that carbonado can form from the Earth's mantle, Cardigny says. A definitive answer, however, may only come from finding more of these black diamonds. Perhaps one will contain an inclusion of material that points to an unambiguous source, or it will be embedded in a host rock that reveals its true origins. In the meantime, the enigma stands as a brilliant and ancient reminder of the many wonders and mysteries